Hi everyone. In this lesson, we're going to talk about parallel and perpendicular lines. So we're going to use a lot of the video concepts from the last lesson and just apply it to what we know about parallel and perpendicular lines. So the purpose is to construct equations that model linear relationships with the special properties of parallel versus perpendicular, as well as being able to determine the slope of parallel versus perpendicular and use that to construct an equation for a line. So just a couple of highlights, some that I hope you already remember, but parallel lines never intersect and they have the same slope. This is going to be the big thing. As you can see, I have two parallel lines, one in blue, one in red right here. And you notice that they have different y-intercepts. The blue line appears to be crossing at roughly the 6.5 mark, whereas the red appears to be crossing at the -1 value. So these two lines are, like I said, similar in that they have the same increasing rate, but different y-intercepts. So it's actually pretty straightforward. If I know I want a line that is parallel to this line itself, but we want it to go through specifically the point 1, 3. So hypothetically, I can test to see if this line already meets that criteria by substituting x and y. So 3 equals 2 times 1 plus 3. That's 5. Yeah, so that's not the right line. But what we do know to be in point slope form, because remember, that's going to be our base to start. We need y minus y1 equals m times x minus x1. We have the point. We have the x and the y coordinate that we need. What I need now is I need the slope. And if you think back to the definition of parallel, that means that they have to have the same slope. So knowing that this is in slope-intercept form, I know that this is a slope of 2. So I can just replace my slope here. And I do want to write this in point slope or slope-intercept form, just so you can see what it ends up being. But distributing and solving here, I get 2x minus 2, add 3 to both sides, 2x plus 1. And you can see if I compare my slope-intercept form here to the one I just solved, same slope, different y-intercepts. Now, this next question here isn't asking for the line itself, but it's saying, what is the slope of the line that is parallel? Well, again, I want the slope of the line that's parallel. But remember, parallel lines have the same slope. So let's simplify this. I just want to know what is the slope of these between these 2 points. So remember our formula, y2 minus y1 over x2 minus x1. x1, y1, x2, y2, 16 minus 4 over 9 minus 3. And I get 12 over 6, which is 2. So if the slope of this line is 2, then the slope of the line that is parallel must also be 2. Now, perpendicular lines are slightly different. They do intersect, but they do something very specific. They form 90-degree angles. So right here between the red and the purple, all 4 of these angles would be 90 degrees. Because at an intersection, if one is 90, all of them are 90. Now, they're not the same slope. They have what we call the opposite reciprocal. And those 2 words have a meaning each. Opposite means a sign change. So if it's plus, you make it minus. If it's minus, you make it plus. And reciprocal meaning the fraction is flipped. So right here is the perpendicular sign. So if you see that upside down T, that's what that means. So for example, the slope of my red line appears to be 3, 1. So it's perpendicular slope. That's how we would read this. Perpendicular slope would be, so it's positive, so make it negative, and take the reciprocal. So anytime you want the slope of the perpendicular line, you would use that value if the original line had a slope of 3. So let's look here. So again, same equation, but now we want its perpendicular slope. So first, let's identify the slope is 2. So that means its perpendicular slope would be -1/2. Now again, we always start off with the point slope form. Y minus y1 equals m times x minus x1. I have my coordinate points. So y plus 1 equals x minus 2. I left this blank for a purpose. So I want the slope. Now remember, not just any slope. I want the slope of the perpendicular line. So it's not going to say perpendicular. If you want to write that in, that's fine. But you want to identify which one you want to use. So this is the slope I want to use. I'm going to distribute. And let's put this in slope-intercept form. So negative 1/2 x plus 1 minus 1 minus 1. So actually, there is no, or the intercept here would just be 0 in this case. Now again, what is the slope of the line that is perpendicular to the line containing these points? So again, I can find the slope of these 2 points by using my slope equation. So here I get 12 up top, negative 2. So my slope is negative 6. Now that would be the slope of anything parallel, but since I want it to be perpendicular, I'd have to first change the sign. And if you remember, we talked about this in a previous lesson. Any whole number could be made into a fraction. So let me think of this as 6/1. And if I take my reciprocal, the perpendicular slope would be positive 1/6. All right, so now our last example here. So I'm at number 7, and I have slightly different wording on your note sheet. So I want you to make sure you're following along with that one. So we want to find the slope of the line that is parallel and perpendicular to a line that contains these 2 points. So we're going to find 2 equations here. One that's parallel, one that's perpendicular. So we just put the slopes. So first, let's find the slope of just the line itself. So y2 minus y1 over x2 minus x1. And we get 4/2, which gets me a slope of 2. So the parallel slope is 2. And the perpendicular slope is, take its opposite reciprocal, negative 1/2. Now we want to modify the equations and use our information that they go through the point 1, 3. So again, we're going to start with point slope form. So let's start with the parallel one first. So we're going to y minus 3 equals 2 times x minus 1. And again, I'm going to distribute the 2. Whoops, that 3 looks a little bit weird. I'm going to add 3 to both sides. And that's our first line. That's the parallel line that goes through that point. And now I'm going to do part B, which is the perpendicular line. So I'm going to do the same thing, but again, my slope is not going to be the 2. It's going to be the negative 1/2. So again, with some distributing, oops, I did a little bit too much there. I get negative 1/2 x. Negative 1/2 times 1 would be plus 1/2. And now when I add 3, I get y equals negative 1/2 x. 1/2 plus 3, so remember when I add a whole number to a fraction, I got to use common denominators. So times 2 times 2, so this would be 6/2 plus 1/2, which gets me a total of 7/2. So again, these 2 equations are based on the same information. We found the slope between a certain set of points, one being parallel, one being perpendicular. We found the fact that we want them both through this point 1, 3, and you can see how different the equations of the line are. But do you see how we use the same information in terms of the points? We just changed out the slope where we wanted them. Okay, well, I hope this was helpful on writing parallel and perpendiculars. And let me know if you have any questions. See you in the next one.